So today I didn't finish the last example. We're going to go ahead and do that in this video. So we're graphing 4x squared over x squared minus 9. So the first thing to notice here, because we're going to want to find the vertical asymptotes, is we can factor the denominator. So that's a difference of squares. We can factor that as x minus 3 times x plus 3. And so we can see that our restricted values, or the values that cause our denominator to be 0 and make us undefined, would be 3 and negative 3. So those are the restricted values, and what we learned is that's where we're going to have our vertical asymptotes. So at x equals 3 and x equals negative 3 are the vertical asymptotes for this graph. So basically our approach is we're going to find the vertical and horizontal asymptotes. Then we're going to try to find a couple of points. We find the x and y intercepts, if there are any. There's certainly going to be a y-intercept. There may or may not be an x-intercept, or there could be more than one. And then once we do that, we'll plot a few other points to help us draw the graph. So let's find the, actually I'm going to put in the asymptotes here. Let's find the horizontal asymptote next. And you can see the degrees here are 2 in the numerator and denominator, so this is what we call balanced. And so we're going to want to take the coefficients of the leading terms, the 4 and the 1 here. 4 over 1, that's just 4. So y equals 4 is the horizontal asymptote. Let's go ahead and find the y-intercept. We know we want to let x be 0 to do that. And I'm just going to use the y notation instead of f of x. So y is equal to 4 times 0 squared over 0 squared minus 9. We're going to get 0 over negative 9, or 0. So the y-intercept is 0, 0. Let's go ahead and put that in. Notice that's also the x-intercept, but it is possible there could be other x-intercepts. So let's go ahead and see what we get when we let y be 0. So we're going to get 0 equals 4x squared over x squared minus 9. We'll multiply both sides by x squared minus 9 to clear the fractions. And when we do that, we're going to get 0 equals 4x squared. And 4 times some number is 0. That have to be 0. X is going to have to be 0 here. And so that is our one and only x-intercept. So now it's time to find some points. So as you look at the graph, we have the point 0, 0. It'd be nice to know what the value of the function is when we plug in 1 for x or 2 for x. So I'm going to go ahead and do that. So if I let x be 1, then we're going to have y equals 4 times 1 squared over 1 squared minus 9. In the numerator, we're going to get 4. And then 1 squared minus 9, that's 1 minus 9, which is negative 8. And so we get negative a half here when x is 1. So I'll go ahead and put that point in. And let's go ahead and find when x is 2. We get 4 times 2 squared over 2 squared minus 9. So you do the arithmetic there, you get 16 over negative 5. Which is negative 3 and a fifth, or negative 3.2. You can use your calculator to help you as you do this. So let's go ahead and put that point in. Now if you look at this graph, it looks like we could have symmetry here based on our asymptotes. And in fact, this is an even function. And that means we have y-axis symmetry, which is going to help us here. It'll save us time in finding points. Remember, to prove that a function is an even function, you just plug in minus x into the function. And if you get back the original function, which we will in this case, you have an even function. So if I plugged in minus x for x, you know that minus x squared is going to be equal to positive x squared. And in the denominator, minus x squared, that's again x squared. So we do get the original function when we replace x with minus x. And so this is an even function. So that means we've got couple of points we can put on the other side of the y-axis. And so now we can draw the graph in between the two asymptotes, the two vertical asymptotes. Alright, so now we need to look outside of that. So on the right of where x is 3 and on the left where x is negative 3. And again, we really just need to do it on one side because we have symmetry through the y-axis. We'll get points on the other side. So let's go ahead and plug in 4. And when you do that, you should get 64 over 7. And if you use your calculator, that's about 9.1. So I'm actually going to find 2 more points because that's a little bit off the grid here. Let's go ahead and plug in 5. And so when you do that, you get 100 over 16. Again, use your calculator. It's about 6.25, which is 6 1/4. And let's do one more. Let's plug in 6. And when you do that, you should get 144 over 27, which is about 5.3. So be careful when you do this. I know it's got to be careful or you'll get the wrong numbers here. Again, use your calculator to help you if you need some help. And you can see that's what I did as well, especially on the final division. So we get 5.3 when x is 6. So I'm going to use 5, 6.25, and 6, 5.3. So I'm going to go ahead and put in those points. And also on the other side, I'll have the points that are on the opposite side because of the symmetry. And so you can see we know that we're going to have little arcs on the ends. So we're going to have an arc like I've drawn there. And that does it for this graph. So it does take a little bit of time to do this, but the key is to find the vertical and horizontal asymptotes, x and y intercepts, and then a few other points to help draw the graph. And if in a case like this, it's nice to be able to take care of or take advantage of the symmetry. We're not always going to have symmetry. All right, so that's it. That's it for this video.